Hey everybody, welcome back. I'm Deez. This is my workshop, and today I think I want to tackle another small engine. This is going to test my skills and abilities, but why not? I recently, the Indiana Model Engine Show was put on in early October, and I'm kind of sparked my interest in maybe creating another model engine. I've got several plans that I've found and people have shared with me, I've found on the internet, and I think I want to go through these and choose something that I feel like I can wrap my head around and create with the materials that I have on hand. If you'll recall, last year I made a finger engine, the NAMES model finger engine, based off the NAMES design. That's North American Model Engine Society, I think is what that stands for. If you're interested in that build, I've got videos on that. You can also find those plans online. It was a fun little build. In the end, it's not as fluid as I would like it to be. My quality of work is probably not the greatest on it, but it does kind of work, and it kind of looks cool too. So it turned out pretty well. But now I want to tackle one that is steam powered, I suppose you would say, but it'll be air powered, and just see if I can get the thing to rotate and move mechanically. Let's pick a plan, go through the different plans that I have available to me, and see if we can figure out which one we want to tackle, and then we'll just start working through it. This will probably be a multi-part series. I don't know how many videos. Shouldn't be a whole ton of videos, but it will be more than one, I'm sure. Here's the plans that I've got available that I want to maybe tackle. Let's go through this stack of plans that I have. The first one that I have is this MK1 simple oscillating steam engine. It's got some basic components. It looks like something I could tackle. I think I have all the materials that I would need in order to make all these components. This is definitely a candidate. I think this is something I could tackle and make. The components seem to be pretty straightforward, and I'm sure I have material to make this. The only thing is the plans themselves are very, the dimensions are there, so I should be able to follow this. But there's no materials list. Well, I take that back. There is a materials list. But I think I could decipher this one. This is a candidate for sure, to see if I can make this thing and hopefully see if I can get it to function. So that's one option. Now we have a simple wobbler design. Now this has, I don't know, this must be from some program, fall 2006. Pretty old plans, but I think it's for a course of some sort. It seems to guide you through all kinds of stuff in an educational fashion. But it does tell you kind of all the components and parts you're going to need for this thing. Gives you some decent pictures. It does describe how the thing works, and it's like I said, it's more of a educational pamphlet or a program for a class or something that you might take. So here's our parts for when you're making it. You can make the flywheel, valve plate. Anyway, all the components are in the back, and I think this is definitely also a candidate where I could follow it step by step and hopefully make this thing. I also came across like an old, I believe this is an article from Popular Mechanics from a long time ago, and it's just a real simple oscillating steam engine. It looks kind of like an interesting build to make. I think I could tackle it, but I don't think I want to work on this one right now. But I did find these plans online. Pretty interesting looking build. Who knows? I may tackle that one someday, but for now I don't think I want to do this one. Set that aside. The mill engine. So I think they call them milli. Like there's some milli designs. I've got all kinds of other. This is Elmer's mill engine, number 33. The plans are pretty good, but the engine part gets to be a little bit tricky looking to me. I'm not sure if I'll be able to tackle that. Maybe I can, but it looks to be a little tricky there. We got the mill. This is the milli, the one I was talking about. Really small, simple little engine. Seen several of these up at the Model Engine Show last year, not this year, 2024. And they're a pretty cool little project, but some of them are really tiny. That's the size of a dime, and these are your components. But maybe due to its small size, maybe it'd be more difficult to make. I'm not sure. I'll tackle one of these someday, but I don't think I want to do this for my next engine. Then I also found this last one here is the Easy Build engine. Easy Engine Build. Materials almost seems an educational tool. There's tool list, material list. It's pretty detailed to walk you through making all the components. So these plans are pretty detailed. I think I could tackle this someday, but I don't think I'm going to do that for this next engine that I make. And I'll do one of these, either the Wobbler or the steam engine. I think I might, since this is for an educational setting and I'm still learning, always learning, I think I'm going to make this Wobbler. I have everything that I think we're going to need for this. The flywheel is going to be 3 inches round. It can be aluminum or steel. I want to go something a little heavier this time. I'll see if I have some steel. Otherwise, we'll use aluminum. I do also have another option I may choose. The valve plate, that's 1/2 inch thick steel. I'm sure I have something. I'm going to see what I have. I need it 5 inches by 3 inches. If I don't have the material, I've been meaning to get over to our steel supply, and this gives me a reason and to go there, and a material list perhaps to pick up some extra stuff. The base is also 5 inch by 1/2 inch thick. Is also 5 by 3. So the valve plate and the base are the same. A cylinder is going to be 1 inch square, 2 1/4 inches long. I'm sure I have something for that. And then finally the piston, I think it's 3/8, 375 thou. Round rod, 2 inches in length. I'm sure I got all those materials. Let's go shopping and see what we have. Hopefully we have everything we need. If we don't, we're gonna maybe need to pick up some of this material here. Well, I think the tricky material to locate is gonna be the flat stock for the base and the riser. It's not 1/2 inch, but I've got these plates that were given to me scrapped from my brother. These are 385, a little over 3/8, I believe. Before we get started with that, let's look at maybe the flywheel here. This was given to me. It's a kind of a pre-made one. It's already threaded. I might be able to use this in the project, so I'm gonna see about cleaning that up and using this piece. But if it doesn't work, I've got this aluminum here. I could cut a piece off of this and we could use this. That's an option. This as well, which is an option. I bought this up at the model engine show, so who knows. Let's just gather these materials. These will be our potential flywheel materials. Next, valve plate, 5 inch. I need 1/2 inch stock. I've got this 1/2 inch piece. It wouldn't have been big enough anyway. This is 1/2 inch thick, and it's just at 3 inches long. I do have some 1 inch brass. This might be our cylinder. I don't see any reason I can't use brass. So that'll be the cylinder. Crank disc, I need a 1/4 inch thick, 1 inch round bar, which I have lots of steel for that. Let's go back to the steel here. I've got, let's see what I have on the 12L14. I like to use that stuff. But I've got the steel for the crank disc, so we're good there. The crankshaft is 1/4 inch round rod. I've got plenty of that stuff. So here's for the piston, or for the crankshaft. And the piston, I need 3/8 round rod. I think we have everything except the valve plate and the base. I'm going to keep looking around for something for those, but for now, this project's on pause until I can source some materials. Well, I need to get some 1/2 inch plate, steel plate. I'm going to keep looking for some materials to see if I can keep going with this project before I can source that. But I've been meaning to get back to my steel supplier, so I'm going to use this as an opportunity and an excuse to get over there and see what kind of scrap materials they have laying around and get some stuff purchased. I did remember that I have an inch round stock here that I got from them. It's 2 feet long or so, and I'm going to use that for the crank disc instead of the scraps and other things that I was picking. We're going to use brass for the cylinder because that's the 1 inch material I have, but I'll also see what the steel supplier has, and we'll just go from there. So we've got some of the materials, but not all of them. I'm going to put this project on hold until I find those materials, but for you, it'll be really quick. So I picked up a nice selection of flat stock and other materials for future projects, but most importantly for this project. I've now got the stock that I need per the drawing, and I'm kind of happy about that. I was going to use this scrap steel and cut some pieces off. This is 3/8, but I'll save this for another project another day. The project itself called for 1/2 inch plate, 3 inches by 5 inches. It was a nice visit with the steel yard. I can go there anytime. I can talk to them. They got all kinds of scraps. I can even order specific parts that I need. If I ever get into welding, I can get materials from them, order them, and I can make shelves or whatever. That's way down the line. I would like to get into welding someday, but it's not going to be anytime soon because that's a whole nother thing. I'm going to have to pay, purchase and learn and understand, but I do want to do it someday. Anyway, enough of this little sidebar. Let's get back to that model engine. I think I'm going to pass on the flywheel for the moment because I'm not sure I want to use aluminum. I want to see if I can make this thing out of brass and steel. I have this 3-inch piece of aluminum that could make the flywheel. I do have another piece that I really wanted to use, but it's not 1 inch wide, and I also need a boss that's a 1/4 inch protrusion from the side in order for the mounting mechanism. So I'm going to hold off on this. We may use this, but I'm going to see what I can find instead of that. So let's move on to the next drawing, and that is the Wobbler valve plate. Now earlier I said I was going to use some 3/8 material that I had in stock, but I ended up making it. I just shared that with you, but I made it to our metal supply store, and I got some 1/2 inch plate, and the dimensions for this thing are 3 by 5. Well, I got some 3-inch flat stock that is 1/2 inch, 3 inches, and I got plenty of length there. I got a couple pieces of this, so we're going to use this to make this part. I'm going to need 2 of these because the Wobbler base is also 3 by 5. So I need 2 of these parts. We might as well cut them both out at the same time, and then we're going to work on the valve plate first, and then we'll move on to the base, and maybe we can get those 2 assembled. going to change. I'm going to use this side. This is a cut off side. I'm struggling over here. This is probably hot rolled steel, and the end on this side is kind of misshapen, and since I want two identical pieces, I want to mill them together to clean them up. What I'm worried about is I'm going to have to take more off of this piece than the next one, and I think that's just going to be more of a pain than I want to mess with. So let's come here. We're going to do 5 1/8 so we have material to cut off and shore up. I want these. Well, you've seen enough. I'm just squaring this piece up. I hit 5 inches right on the mark, plus or minus a thou. I'll take it. I'm just going to go ahead and square up the other parallel sides as well as clean up the mill scale off of this. I'm going to use a wire wheel because I don't want to mill off any of the thickness of the 1/2 inch material. If there's a lot of pitting or problematic, if it's a problem there, then maybe I'll mill it off. I'm going to go ahead and I'm going to try the fly cutter and see if I can clean up these, just take the bare minimum amount of material off of the remaining 4 sides. This mill scale, that Harbor Freight wire wheel that I have is kind of crappy anyway. I could probably get most of that off, but I think I'm going to be happier if I go ahead and mill that off and have a nice complete piece with all mill sides to start with. Well, we have our 2 plates milled, cleaned up. I used the face mill. I used the square inserts and the round inserts for my face mills, my 2 different face mills. And I've got everything pretty much chamfered. There's a little spot right there. That's better. Just missed this side. There we go. So we have our 2 plates ready to go. So I went ahead and milled these together just to save a little bit of time, and you can kind of envision if we go back to the main first page, what these two pieces are going to be. So these are going to be mounted like that. Let's go ahead and move on to the valve plate. So we only need one of these. Oh, I did want to measure these real quick. How much did we take off? I think I took off about 20 thou from the 1/2 inch. So yeah, 20. I think it's about 25 thou. Yeah, so I took 25 thou off of that one. And 30 thou off of that one, just to clean up the mill scale. I tried to use that wire wheel and that wasn't going to work out very well. I like this better. We got some nice pieces to start with. Everything's squared up. It's time to move on to the valve plate. We need to do some layout, some marking, and I'll also use the DRO to put where I want things to go. But I think I want to mark it just to kind of give me a visual reference of where I'm going to be putting things to kind of keep me honest. I'm definitely going to use the DRO to drill the holes that I need to do. One thing I was reviewing on the valve plate, it's not real clear how far in I'm supposed to go for the threaded holes on the bottom. It's missing that information. Now, the information is on the base. It comes in 3/4 of an inch, 750 thou from either end, or 750 thou and then 3.5. So I know that that's the dimension I need for these, but I think I'm gonna work on the base first, just so I can get the holes done and that portion of it done. And then we will move back over to the valve plate and drill these holes that need to be done and tap for the bottom. But if I need to, I can actually use a punch to transfer for these holes. On the base, we know we need to come over 750 thou. So we're just going to use, the DRO like I said, but this is just going to give us a visual, kind of help keep us in line. well, we got the base plate done. We got one of the components made, but I'm not going to stop here for this video. We need to make the riser, the valve plate now. Correct me if you know something that I don't. Why don't you post it down in the comments, please. But this wants me to tap 1032 1 inch deep. I can do that. But this is saying the hole is 1900. Now, that would be after the threads. I mean, if I was to drill it 1900, or sorry, 190 thou, that's going to be bigger than the actual threads on the 1032. So I'm going to go with what I know, and I'm going to drill it with an 11/64. That'll give me, it's a little bigger than the standard tap chart, but that'll give me a little bit easier time getting through that material. So I'm going to drill these 1 inch deep for 11/64 so that I can then tap them for the 1032 thread. I'm not sure what this is. It's either a mistake or I'm missing something, but I'm going to go with what I know because these two pieces are going to marry together. Actually, before we even start with the rest of the layout, let's go ahead and do that so that we can marry these two together, because if I break a tap or I screw this piece up, I got to remake all this anyway. Let's get that done because I think that's going to be my trickiest task, and then we'll see if they fit together. The two holes drilled and tapped as per the instructions, other than this mystery 1900 circumference. Maybe that's after, whatever. My test fit works. Now I'm really curious if these two parts marry together, because I didn't do a transfer punch. I used the DRO. I suspect they'll be just ever so slightly off, but let's do the first test fit right now. Let's see, I'm going to need that. Hopefully this fits. That goes in there. That goes in there really nicely. Both these are flush or are below the surface. This lined up pretty good. It's just a little off. I might flip them around. Maybe it'll line up better the other way. Let's try that real quick. But these, I'm really happy with this because I didn't do these together. You know, you did one. When you're working on parts that are not together, and then you have to reset up your work pieces, it's really satisfying when the two pieces actually come together like you intended. And you know, I didn't have these together when I drilled the holes, so let's see if this is any better this direction, because at this point it doesn't matter. That's just a little adjustment maybe. I think I can get these pretty spot on. Yeah, right there. I like it. Okay, so we got that part done. Well, everybody, I went ahead and I reviewed these instructions, and I'm glad I did. This is a really good stopping point now. I know I said I was going to continue on, but I can't drill those holes yet. I could drill some of them, but I don't want to get this set up and have everything going. I need to get some more parts for this model engine. So I need to get some barbed fittings. All I have are these, but they need to be threaded on one side. This is why I'm glad I read ahead, or read through the other instructions, which I should have done anyway. Where I need to drill the bottom, you know, I've got these two holes here. One's a through hole and one has a tap. Well, that's based off of the threaded barb here. I might find one that's a little bigger. So I need to find, I'm going to find what they use in this drawing, but if I can't, I might have to tweak that a little bit. And that could have been a problem had I went ahead and drilled those holes. I did not mess this up. I went back and looked. This is how this is supposed to be, the mounted portion. So we did a lot of work today. It doesn't look, I mean, that looks like a pretty simple part, but it takes a long time to get to this point, especially when you're cleaning the material up. I'm really happy with how well this turned out, how the edges are lining up by doing just both of these pieces independent, and it really turned out really well. So I need to source some more parts before I continue on, but this is going to conclude part 1 of the Wobbler model engine build. And again, there's the design I'm using, and I'm having a lot of fun. This is, you know, if I just slow down and I break the parts out and I just work on each drawing, I can handle it. It's just sometimes you think, I don't think I can build that. Just give it a shot. If you're interested in it, just have at it. What's the worst that could happen? Doesn't work? Big deal, right? Well, everybody, thanks for watching. I hope you enjoyed part 1 of this model engine build. If you haven't subscribed, please do. Really helps out the channel. Thanks for watching, everybody.